Okay, so this is a review over net ionic equations. You got this after Unit 7 test. You watched the video over it. We went over it in class a little bit, but here is just some review on it. All right, so let's go to the back. I think a lot of you got to the front. Oh, let's do one on the front, and then we'll go to the back. Okay, so let's do number 3 here. Strontium bromide. So strontium plus 2, bromine is -1, potassium sulfate, SO4, plus 1, -2, strontium sulfate, plus 2, sulfate is -2, potassium bromide, plus 1, -1. And so that's just the testing strategy that a lot of you probably should be doing, is writing the oxidation states of all of these ionic compounds. And I know we talked about oxidation states before, but since this is ionic, we can go straight from our periodic table that we've learned since the beginning of the year. Okay? So, strontium bromide, SrBr2 plus potassium sulfate yields strontium sulfate. I'm just crossing up all of these charges. That's where my subscripts are coming from. And then potassium bromide, that should be a large K. There we go. Okay, so now we should look at solubility. So strontium bromide, I believe, halogen. So when I look at my solubility here, see if I can get both of these in. Strontium bromide, bromine is a halogen, strontium is not an example, so this is going to be AQ. Sulfate is down here, and these are the exceptions. Potassium's not one of them, so I can go there. Strontium sulfate here, and look, strontium is an exception, so here's going to be a solid. And then KBr, I know both of those, that's group 1 and a halogen, so that's definitely going to be aqueous. Okay, so the reason I had to do that is because now I need to break apart all of my aqueous. I'm going to keep my solid together, which is what we see up here in the example. Okay, so for my complete ionic, I'm going to break all of these apart. Sr with a +2. Well, good thing I had that. And then I have, that's added to, well, before all that, I'm sorry, I need to balance this. So we have 2 BRs here. I should put a 2 there. That takes care of that. And so we're good there. And here, notice how there's a 2 subscript. Well, that means I'm going to put a 2 here because I have 2 BRs here. Each one has a -1. Then that's added to another aqueous thing. So I'm going to break apart all my aqueous. And there are 2 potassiums, each with a +1 charge, and then added to 1 sulfate with a -2 charge. So notice I'm breaking all of my aqueous solutions up, and this one is a solid, so I'm going to keep my solid together, right, which is what we see up here in the example. Notice how this AgCl stays solid. We don't break, or it stays together all the way through. And then I'm going to add that to I have 2 Ks here, that's a +1, and then added to 2 BRs. That 2 goes to both of them. I'm going to tell you why here in a second. BRs with a -1, all right? So then I need to cross out, separate into the respective ions, which is what we did up here. Now all of these crossing out is from their spectator ions. These are all spectator ions. So spectator ions are those ions that are found in aqueous solutions on both sides. So they're split apart on both sides. Well, if I look over here, these 2 are not split apart, so these cannot form spectator ions. So if I look here at Ks, my Ks are split apart, and look, I have 2 of them. That should match. So I'm going to cross those out. So my spectator ions, if you ever have to list those, are those that are split apart. So my first spectator ion is potassium. My next spectator ion, if I look at bromine here, I have 2 of them, 2 of each because I balanced correctly. My second spectator ion is bromine, right? Now those spectator ions will not get brought down to my net ionic, just everything that's left over. So I'm just rewriting this equation without my spectator ion. So I have Sr +2, and then that's added to sulfate with a -2, that yields, and then once again, once I find my solid, that solid gets brought all the way down to the bottom, SrSO4. There you go. Okay? It's the same thing for all of these. Now, I believe number 5, if you look at number 5, both of your products are aqueous, which means when we get down here to our complete ionic, so I should be able to balance it and write everything out. I should be able to write my complete ionic, and what I'll see is that everything is split apart, like up here, but without a solid, right? Everything will be split apart, which means I should cross out everything because all of them are spectator ions, right? I still need to see this complete ionic with everything crossed out if the reaction doesn't happen. Then in my net ionic, I'm going to write NR because everything is crossed out, okay? Now on the back, it's the same exact thing except I don't give you the step by step, but you should still do all of your step by step. You should still balance. You should still give me complete ionic, and then you should still give me the net ionic. And it's the same exact process as what we did here. And if you have one where both of them come out to be aqueous as a product, you should still write the complete ionic and cross everything out because everything's split up because it's in an aqueous solution. And then at the very last step, you write NR. The only thing that you really wouldn't do here is balance, okay? You should still give me, instead of the balance, it should be the skeleton equation, okay? The skeleton equation. Now, if you happen to balance it, that's okay. Just down here in the net ionic, I should see no reaction. All right, I hope that helps.